Welcome. In this video, we'll actually demonstrate how the iVision TPM user interface and integration collector should be demonstrated. We will first take a look at the initial setup of the server to ensure that we have our True Portal running. Just log in, verify that the True Portal is running. Go to the jobs in the data admins, go to the jobs and ensure that the jobs have the iVision jobs, iVision TPM configured. If this is not configured, we'll need to go to our iVision installation folder, go into the configs, and import the compound, extract, transform, and load jobs. Once the iVision jobs, iVision TPM job does exist, ensure that there's no data in the portal. So we're going to start with the greenfield environment, go into the data and types, click on search, ensure there are no software product and hardware product versions available. We have some helper queries, the 5 or 6 helper queries that we can configure in our composer. If you don't have these configured, again, go to the iVision installation directory, go to the configs, and there is a TQL helper queries, TQLs 1 through 7, that can be configured. The name of the query, the label is provided, and simply create one TQL query after the other, and then attach that in the solutions composer in whichever a browse or data and types page that's required. I've attached mine to the admin data and types tab, and I have these queries available at my fingertips. So again, ensure that there's no data and ensure that the jobs is configured. Once the portal is up and running and this is verified, we will close this out. Go into our configurations for the iVision TPM collector. We will go into the installation directory resources file and open the data collections file. In this file, we had configured the settings for our license keys prior. Now we're actually going to ensure that the REST API setting is set to true, and our internal lifecycle setting, let me zoom in here, the internal lifecycle is set to false. So in this initial configuration, initial run of the collector, we will not get any of the information pertaining to the internal lifecycle. Once this is done and the license keys are configured, simply close out and run the iVision TPM collector. Before we run the iVision TPM collector, one thing to double check is to ensure that in your data collections file, that as you scroll down, there are two properties on how to pull and push data from true. If these properties are set to false, ensure that the properties are set to TRUE as the value. Property key is pull initial data upload file from true, push data into true after Technopedia. Ensure that those files are indeed set to the value of true as the boolean. Once that is done, again, close out of everything and launch the integration program. One thing we will want to do to launch the integration program is to ensure that our filter files are configured, and to test and ensure that Technopedia is working, we click on the Get Data by URL. Simply click on the Get Technopedia Data. We will go out, make a call to Technopedia, and bring back a JSON file, which we can ensure that there is communication between the iVision TPM collector and the Technopedia catalog. Once that's done, we can go to the filter files. If you have any content in the filter files, just navigate through all the tabs and go ahead and clean out or delete all the values. Once that is done, we will look at our demo data and pull a list of IDs. Here I have a list of IDs from Technopedia that I want to configure in the iVision TPM collector pull from. So I will again click on Filter Files. I will click on Multi-Fill. Once I have the load software, click on Multi-Fill, paste my software release IDs, and do the same for the load hardware. I have 4 hardwares here identified. Click on the iVision TPM Filter Files, Load Hardware, Multi-Fill, ensuring that I have the hardware model ID selected. Click Done, and Save. What essentially this does is it configures the iVision TPM collector to pull, in our case, 11 software products and 4 hardware models from the Technopedia catalog to push into the true portal environment. Once this is saved, click on the Information tab. The command line utility that we want to use is the iVision collector.exe with the parameter sync with Technopedia. So I will make a copy of this. I will close my Notepad and Files, and I will launch Notepad in administrative mode. Navigate to my iVision TPM folder, installation folder. I will paste the iVision collector.exe sync with Technopedia parameter value, and I will launch the exe. What this will essentially do is it will go into the true portal, extract the data first. Close Notepad. We'll extract the true content of the iVision previous load directory, and you will notice that the content is extracted from the true portal. In our initial case, there is no software, products, hardware models, so this file will be empty. The file on my clock is November 7th, 9:42 p.m. Once this is done, the iVision TPM collector goes through pulling the information from Technopedia. It does a merge or an update with the information from true, and it outputs information in the output directory once completed. It takes about 1 to 2 minutes to run the collector for about 11 software products and 4 hardware models. Once this is done, if you launch the True Portal and go to the Jobs menu, you will see 2 jobs that are submitted by the iVision TPM collector. One is the ETL job with some delete instances, and one job with the iVision TPM job, which contains the information for the neural updates and creates. Go to the Data and Types tab, click on Search, and using our configurations that we've done previously, we can now search for the software models and the hardware products. So let me change this just to return the software models. We should have 11. What we actually pull from the Technopedia catalog is the software product version. Along with that, we pull the lifecycle that is mentioned in Technopedia, and we pull, or have the ability to pull, the standards category, the software product that software product version belongs to, the organization that sells that software product version, and the internal lifecycle. So all this information is being pulled for the software product version. For the hardware product model, we are pulling similar information. For the hardware product model, we will pull the standards category, the lifecycle where available, the organization that sells, the hardware product model, and the hardware product that the hardware product model belongs to. In both cases, we do get the lifecycle information as well, as we see with this ASP.NET and the lifecycles in the lifecycle tab. All the information that is extracted and pulled is the same information that's available in the out-of-the-box semantics. There's no meta model changes. Therefore, the insight views that are configured and the portal layout screens that are configured will all continue to work. That is all for the initial piece of the demo where we show information coming in. One of the things that we will do now is show the update capability of the iVision TPM collector. We will run the collector again, simply the same information, but in this second run, what we will do is we will change some of the parameters. In the parameters, what we will do is we will open up our data collections file, and where we have the settings for the include, there is a key for include internal lifecycle analysis. We will set this to true and save. And what will happen here is we will run our command line utility. And what will happen here is it will actually save the information about the internal life cycles based on the manufacturer life cycles. There are some rules that we apply to the internal manufacturer life cycle, where for generally available, end of life, and obsolete are the phases. For the manufacturer life cycle, we have 4 approved, preferred, phase out, remove, and denied for the internal life cycle. And based on certain rules, 6 months prior, 18 months prior, we can stagger the phases based on manufacturer life cycles within the iVision of Technopedia and True. So we'll run this. Hopefully the read schema won't cause a problem. Again, data is extracted and placed in the previous load. In this case, the data extracted from True contains information about the software product versions, the hardware product models, the external organizations, the standards category. All that information is pulled in to the loading file. Information is analyzed with what's in Technopedia and exported out as output files. And once that's completed, jobs are submitted into True to ensure that the data is updated and reflected. Once these jobs are completed, we can take a look at the data again. In this case, Data and Types tab. We can search for the hardware and software models, search for the software product versions. And in this case, if I click on the software product version, where we had the manufacturer lifecycle, we can see that there's an internal lifecycle created, and this internal lifecycle will be managed by the integration from now on. It can be controlled by the organization if required and changed, but overall, a general rule is applied to create these internal lifecycles. One of the things that the collector does do is as it runs, it does write to the log file. I will actually run the user interface to show the logging capability. Once you open the iVision TPM collector UI, within the logs, you can actually see what information is getting created and deleted, if there was any, and how that information is getting populated into True. This was the last job that we ran. The previous one at 942 with our product logs. You can see here that they were hardware products and software products that were created along with software product versions, external organizations. So there is a detailed log of the instances and the links log, which is the relationships that is created for each one of the iVision TPM collector. In this section, we will show how the eDNA normalized information is brought in through the iVision TPM collector. One thing you want to make sure is if you have your SQL Server Management Studio, that you do have a sample of the eDNA published database. Otherwise, this section will not work. This information can be obtained from the iVision or BDNA partner, but the BDNA publish will be required for this section. One of the things that the iVision TPM collector does, it does import information from the BDNA catalog. And it does this in two parts. Once BDNA normalize is part of a customer's environment, there is no need for the customer to configure in the filter files the list of information that needs to be pulled from the Technopedia catalog. Once the customer has BDNA normalize will provide the iVision CPM collector with an input of the list of products that are installed on the customer's network, and that information will simply be pulled in to the filter files. So here I will show, in our last demo, we had 11 softwares and 4 hardware models that we pulled in from Technopedia. This was configured without the use of normalize. With normalize in the picture, what we will do is we will run this query, iVision collector or get product list from normalize. We'll run that query. What this does, it queries BDNA, and it runs pretty quick. It queries the BDNA publish tables for a list of products that have been normalized in the customer's environment through the scans. And what we'll find is, once that is done and we load the files again, that information is extracted. In this case, it didn't work because my configurations for the BDNA publish tables have not been done correctly. So I will double check and configure those that information for the BDNA publish database. And once we do that, our settings will work. So what we will do is we will go into the iVision CPM collector. We will go into the resources directory, into the data source, and we will configure our BDNA publish tables to be localhost, database server, the same username and password for the SA account on the server. And with that information, we will be able to connect to the BDNA published database table. Again, once the information is saved for the data source, we can come into our command utility. Just again, review that in our user interface, we do have in the filter files the 11 and the 4 software products and the hardware models that we were extracting. We will come into our initial page, information page, copy the get product list and normalize. We'll paste that. Once that's done, what's actually happening is the customer doesn't need to provide us with the list of 11 software products and the hardware product models. We will extract that information from normalize. The benefit of actually having normalized in the picture is that the customer need not provide the 11 software products and the hardware product models, but instead we will get all of that information from the BDNA published tables. So we'll rerun it. Once that information is completed, within the filter files, we will load the information to refresh the data, and we will notice that all of the software product versions and the hardware product models are pulled into the environment, and this is basically what we would be using to normalize our data, rather than the user typing in, providing this information to us. So again, with Technopedia's, with BDNA's normalizing the picture, we don't require the customer to add in any of the information for the technologies that they have in the network. BDNA normalizes using the discovery tool, normalizing that information. Those IDs are immediately brought in, and then these are the IDs that we will pull and get the lifecycle information for in the process. What we'll also do is through the get asset product links, We will take the servers and create server instances for all the servers that are within the user's discovered data. We will link those to the software product version through the software modules, so those will also get created when we run the iVision collector, get assets to product links, and all that information will be populated into True. For demonstration purposes, we will launch our user interface again. We will go into the filter files. We will remove everything except the 11 software product versions. Go ahead and delete as selected. And then we will delete the 102 hardware product models as well. And in place, we will put in our demo data. And in this case, we'll just do it for the software product versions. We'll save. And now we will do it for the hardware product models as well. So we'll go back to our filter files, just having these 15 instances in multi-fill. And what we will do is we will actually demonstrate the use of the get assets to product links. And here, what we are trying to do is we're trying to go to normalize, and we will show how the asset information, the servers and the software modules gets pulled in. So let us go to the information tab, copy the link, the last link. We'll close some of these windows. And here, we will get assets to product links. Again, what we will do in the integration is go into True, extract out the information from True that exists in the True portal environment. We'll extract that information into the loading file. We will query the necessary information in BDNA normalize database, and we will correlate that to what servers need to be created and what products need to be created on those servers. Once we do that, we will go to the jobs job screens to see the new jobs getting loaded. The clock is at 10:15 for me. And this job sometimes takes a little bit longer because what we are creating is we are creating all the server instances and all the software module instances for those servers. So once this is done, usually it takes about a few minutes. You will notice that in the Data and Types tab, currently we don't have any servers, but we will see servers down here as well, or software modules rather. To show this information that is getting saved in the tux file, we go into the iVision installation directory, go to the outputs folder, and in the updates, we can actually see that all these servers are being created. And associated software modules be created as well. That link the server to the software product version. All this information will be kept in sync over all the runs. You can look at the jobs and the details. I will actually go and look at search for the software product versions again. We can pull the Windows Server 2012 and look at all the related components. Here we will see that based on the normalized information, software product version, Windows Server 2012 Release 2 is installed on 247 assets. And all those assets are brought in through the software module links. If you look at the software module link, you will notice that it attaches to both the software product version and the actual server that has the software product version installed. All this information is getting synced on a continuous basis. So we are bringing in the servers, the software modules, software product versions, the hardware product models, and their relationship to servers as well. We can see that within our search. We search for a hardware product model. Those hardware product models identified will also be brought in if they have servers attached to them. Here are the hardware product models deployed on 89 of these assets, and that information is brought in as well. Thank you.